Hi, Mike Almale, CPA Business Appraiser, back with this last time value of money video. Every time value formula I have introduced in this video series contains this expression or one very much like it. Now suppose the interest or discount rate I is 5% and the compounding periods N equals 8. The above general expression would be converted to this specific expression. Just a few decades ago, before the advent of powerful handheld calculators and Excel spreadsheets, evaluating an expression such as this would be a bit time-consuming. Of course, you would not have attempted to multiply 1.05 times itself 8 times. Either you would have used log and anti-log tables or a slide rule. Now, if you've ever had to use these methods, you would have an even greater appreciation for the miracle of present-day calculators and spreadsheets. But these new powerful tools have their drawbacks. Excel and calculators do not just evaluate this one component of time value formulas, they evaluate the entire formula. Why would this be a problem? Well, calculators and spreadsheet formulas perform time value computations utilizing graphical interfaces in which you have to enter each parameter in a different cell. If you do not provide the correct parameter or the parameter in the correct format, you could easily get a wrong answer and not realize it. It's the old garbage in, garbage out problem. Sometimes the correct format of the parameter is not so obvious. A second issue with Excel is that it offers different functions that have similar names. And finally, the spreadsheets and calculators do not give you an obvious way to validate the accuracy of your results. For example, Excel offers two very similar sounding functions, PV for present value and MPV for net present value. The PV function can only be used if the future payments are constant or you're trying to figure out the present value of one lump sum in the future. So let's look at an example. Suppose a friend of yours wants to start a new business. She needs about a $10,000 loan from you. Her first offer is a zero coupon bond arrangement paying you $10,000 in 5 years. Suppose you demand a 5% return. How much cash would you be willing to give her now? This is a present value computation. You choose the PV formula in Excel. Here's what it looks like. So how do you know the answer is right? Well, as a check, you can actually enter the basic formula in the cell below this and test to see your result. And voila, you get the same $7,835 number. So now, let's assume your pal really needs more than $7,835 up front. You still want to get your 5% interest, and you do not want the entire deal to involve much more than $10,000 in future or present dollars. Your pal knows that she cannot afford to make much in the way of installment payments in the first few years, but perhaps she could afford 5 $2,000 payments at the end of each period. To make your 5%, what amount of cash are you prepared to lend under these terms? Well, the PV formula works in this case as well. As you can see, in order to yield 5%, you would discount your original loan to $8,659. Now, how do we check this using original formulas? We could do it on a spreadsheet like this. We index the annual payments in the first column and place the annual payment in the next column and then put in our basic formula in the last row. Copy down and sum, and our initial calculation of $8,659 is confirmed. Now suppose, annoyingly, we are not done negotiating yet. Our pal is not sure that she can make $2,000 payments at the end of the first few years. She would feel more comfortable making 0 payments for the first 2 years and a payment of $2,000 at the end of year 3, $3,000 at the end of year 4, and $5,000 at the end of year 5. Now again, given that you want to earn 5%, what would you be willing to lend her under this repayment plan? Now, here, the Excel function PV will not work for this scenario because the repayment stream is not constant. Here we have to invoke Excel's MPV function instead. The function and input look like this, and here are the results. Now, to recheck the results, you can re-enter the basic formula like this. But note that you had to make the cell reference to the interest rate fixed. Here you see that the results match, and you would be willing to front your pal $8,113. Okay, annoyingly again, your friend decides she really needs the full $10,000 now, and so offers another suggestion. How about a fully amortized loan with affordable monthly principal and interest payments? Now, in order to make it more affordable in the first lean years of her venture, she proposes a 7-year payback period instead of a 5-year payback. You counter that due to the extended payback period, you want the interest rate increased to 6%. Now, Excel has the precise function, PMT, standing for payment, to easily compute the monthly principal and interest payment. So you set up the worksheet and the formula like this. Now you blithely enter the cell references as follows and click OK, and you get a monthly payment of $1,791.35. This looks very good to you, but your pal has a seizure and says, WTF? That number can't be right. Over 7 years, I'm going to be paying you about $150,000 on an initial $10,000 loan. I don't think so. So what went wrong here? So you go back to your spreadsheet and you realize that you put 7 years in the NPR, number of periods input, and you should have put in 7 times 12 or 84 periods in this input. Easily fixed. This is an example of getting the wrong parameter value in an Excel function interface. So first you modify your spreadsheet so the actual number of months shows as a separate cell input. So now your input and formula look like this. This time, you have entered your new cell C5, which represents the actual number of months of payments, 84. You hit OK and now derive a monthly payment of only $604.53. This looks better. You happily present this new figure to your pal. She looks at it and says, WTF again? Do the math, friend. If I pay you a little over $600 a month for 74 months, I will end up paying over $44,000 on a $10,000 loan. You told me that you would be happy to collect 6% of the loan balance. The monthly figure you were quoting me implies an interest rate I would have to pay if I get Vinny the leg breaker to lend me the money. So you go back again and get the right figure. So greatly embarrassed, you go back to your Excel spreadsheet and you realize that you were supposed to enter into the PMT interface the interest rate per month, not the annual interest rate. You create a separate cell for the interest per payment period and enter this into the formula input, and you now get a monthly payment of about $146 per month. A lot more reasonable than the previous incorrectly computed monthly payments. But since you've embarrassed yourself twice in inputting the incorrect amounts in Excel, you have to ask yourself, is there a way to independently verify that you finally have the right figure? Well, yes, you can. Recall that the formula for the fixed payment looks like this. Admittedly, an ugly looking thing, but you can actually easily plug this into your spreadsheet and independently confirm that your formula is right. It's like this. And as you can see, the results are identical. Now, you may think that these extra efforts are simply redundant and a waste of time. And yes, these independent error checks are redundant and they take more time. But as I hope this last example shows, it is very easy to input incorrect numbers into Excel formulas and derive embarrassingly incorrect results. So always take the time to independently check your results. So thank you for viewing these time value of money videos.